This is the first mini lecture, textbook section 5.1, in which we're going to begin to talk about the integers. So I'm going to begin with a little story. When I was in the 3rd grade, of course, I had not seen negative numbers in school yet. I had to stay home sick from school for a few days. And while I was at home, I watched some PBS on TV, and I saw a math show. And in this math show, they talked about these numbers below 0. And I was quite amazed by it. And I remember thinking that, for years my teachers had kind of been keeping this thing secret from me. It's like maybe my mind couldn't handle it or something. It's this secret. They've been lying to us for years. They've been telling us that the lowest number is 0. There's nothing before that. And then now I've learned the truth. My eyes have been opened. There are actually numbers below 0. So either the teachers just didn't know about it, maybe because they hadn't gone far enough in math, or they were lying to us. And I remember, telling a friend of mine at school when I got back to school about these numbers below 0, and they thought I was ridiculous for even having that idea. And another story, one of my kids went to school one time. I think she was in the 1st grade at the time. Of course, in our house we talk about integers. And, the teacher said, well, there's no numbers below 0. And, my daughter said, well, what about the negative numbers? And the teacher said, told her to be quiet. We don't want to talk about that yet. So, based on all this, I feel like there's a misconception. It's a misconception that I had when I was a kid, maybe that a lot of teachers have, maybe that my daughter had, that, somehow the negative numbers are sitting there waiting for us to find them, and if we don't talk about them, well, it doesn't really matter because they're there, one way or the other. I think that it's more true to say that we do not discover the integers. It's not that they're there, secretly somehow we don't see them. It's more like we create them. We are the ones that invent the integers. So, we'll begin with the natural numbers. Those are the numbers that we learn to count with. In a manner of speaking, we don't invent those. They're kind of given to us in the world around us. So, 1, 2, 3, 4, and so on. Those are the natural numbers. And we just decide that for each natural number n, there's an opposite, which we call minus n, or negative n, so that the two sum to 0. And in that way, we create this copy of the natural numbers, the negative numbers, the negative integers, rather, the numbers below 0. So here's how the formal definition works. Okay, the positive integers are the natural numbers, 1, 2, 3, 4, and so on. The negative integers are the numbers -1 and -2 and -3 and -4 and so on. So they're the copies of the natural numbers. It's the copies of them that are below 0. And then the integer 0 is neither positive nor negative. So we don't think of it as either. It has no sign. So the integers consist of all of the positive integers, the negative integers, and 0. Moreover, 0 is what we call the additive identity, so that when you add it to any integer, you get that same integer back. And each integer has its opposite. So the additive inverse of the positive integer n is the negative integer, minus n, which has the property that if you add them, you get 0. So these negative integers are the opposites of their partners. Now, you might be used to thinking of minus n or negative n as -1 times n. Because you've been taking algebra for some time now. You've been doing higher level mathematics, and you certainly have seen this many times. Okay, but notice that we haven't actually talked about multiplication yet. Okay, right now we're just introducing the integers themselves. So we don't have any conception of multiplication yet. But we do have a conception of what it means to be negative, or what it means to be the opposite of something. So the definition of minus n, it's more elementary than this multiplication idea. Minus n is the additive opposite, or inverse, of n. So that word inverse means opposite. Okay, another little point of confusion is the fact that we use this minus symbol for two different things in math. Subtraction and negatives. In fact, way back in history, people used two different symbols for this. It turns out to be kind of convenient to use the same one, but if you're teaching, you should be careful not to get them mixed up, because they're used in different ways. So when we write minus n, we mean the opposite of n, not the subtraction of n. So when I write minus n, I'm not talking about subtracting n. I'm thinking about a number, the number minus n. Now notice that if n is positive, then minus n is negative, but if n is negative, then minus n is positive. So that minus sign just switches the sign. If n is positive, it flips the negative. If it's negative, it flips the positive. So it just flips the sign. Okay, so just as minus n is the opposite of n, it is also true that n is the opposite of minus n. So that might seem too obvious to state, but it's something that has to be stated, and I would encourage you to kind of think about what we're saying here. So minus n plus n equals 0 implies that minus n is that n is the opposite of minus n. So I'm adding n to minus n to get 0, which means that n is the opposite of minus n. So minus n is n. The opposite of n is n itself. Now, each integer consists of two parts. It has a magnitude, also known as the absolute value, and the sign, which could be positive or negative. Think about your bank account. If you look at your bank account online, most likely that you'll see two kinds of numbers. You'll deposits and withdrawals. On most online banking, the deposits, the money added to your account, are marked in black. And the withdrawals, the money taken from your account, that's the bad one, that's marked in red. So when you look at one of these entries, there's two pieces of information, right? There's the dollar amount, and there's whether it's red or black. So the dollar amount is like the absolute value or magnitude. Whether it's a deposit or withdrawal, whether it's black or red, that's like the positive or the negative. So you can't interpret what the entry means unless you have both of those pieces of information. So in the same way, an integer contains two pieces of information. Now, in this section, we're interested in representing the integers so we can understand their meaning. So when we represent integers, we'd like to make a few things clear. First, how are the magnitude and sign described? The magnitude is the size, the sign is whether it's positive or negative. How are those described by that representation? Okay, second, how is 0, the unique integer with 0 magnitude, described? So 0 is the unique number that doesn't have magnitude. How is that described? Okay, third, how does the addition by 0 property hold? N plus 0 equals n. How do we see that illustrated with this representation? And fourth, how is every integer paired with its opposite so that n plus minus n is equal to 0? So we'd like to understand how that's illustrated in each of the representations we're going to talk about.